Welcome to section 5.15.2. We're going to be doing proofs, basically, for the first portion of this chapter, and then as we move on to 5.3, we're going to move on to solving equations. So, here we are with our first practice problem, where I've already done the other two in the notes, so the first two, just using a little bit more of the identities. So we'll move on to something just a tiny bit more complicated, and then just kind of work our way up. So, here we've got 1 minus 2 sine squared theta is equal to 2 cosine squared theta minus 1. I think I'm going to go ahead and pick manipulating the right-hand side. So I'm going to keep the left-hand side as it is and just kind of carry it down with me on each step of the proof. So I'm just going to copy down what I have so far on the left, keep it as is, and we'll start manipulating the right. So as I look at the left-hand side, I see that I want sine squared. And on the right-hand side, I have cosine squared. Well, I have an identity to replace cosine squared with sine squared. So I'm going to go ahead and take out the cosine squared here, keep the 2, take out the cosine squared and replace it with 1 minus sine squared theta. Using that identity of sine squared theta plus cosine squared theta is equal to 1. And I'm going to go ahead and just bring down the minus 1 with me. So from here, I again keep copying down the left-hand side. You want every line of your proof to be accurate. So if you don't have anything over there, then you don't really know what you're setting it equal to. So you want to make sure you carry it down the whole time. Let's go ahead and distribute that 2. So if I distribute my 2, I get 2 minus 2 sine squared theta minus 1. Again, carry down the left-hand side. Need to make sure, again, that every line is accurate. So 1 minus 2 sine squared theta, which is what I started with in the first place. And over here, I'm just going to combine like terms. So I have 2 minus 1 at the end, which is going to be 1. And then I have 1 minus 2 sine squared theta. My proof is done. I know that I am finished when the left-hand side of the proof matches the right-hand side of the proof 100% accurately. If it doesn't look exactly the same, then you're not necessarily done. You have to do a little bit more steps. So let's go ahead and move on to the next one. So the next example, we have 1 over sine x minus 1 over cosine x is equal to cosine x minus sine x all over sine x cosine x. Either side of this I don't think necessarily is more challenging than the other. So if we're going to work on the left-hand side, then we're trying to get one fraction kind of all pulled together on the right. So I would need to get a common denominator if I wanted to do the left-hand side. Whereas if I wanted to work on the right-hand side, then I would actually want to divide. So I think for most people, trying to pull things together seems to be a little bit easier for them. So what I'm going to do is I'm going to take the original problem here of on the left-hand side of 1 over sine x and minus, leave myself a little bit of space because I'm going to try to get a common denominator here, of 1 over cosine x equals, again, carry down that right-hand side this time. I want to make sure, again, that every line of the proof is accurate. So what I want to do is I want to try to get the left-hand side as a single unit or as a single fraction, which means I need a common denominator for it. So what I'm going to do, use a little bit of color here, is I'm going to give each fraction what it needs to get the common denominator. So the first fraction is going to need a cosine x top and bottom to get that cosine x sine x. So I'm going to multiply it top and bottom by whatever it needs. On the cosine x over here, it's going to need a sine x. So I'll multiply that top and bottom by sine x, just to get, again, the common denominator that I need. So let's go ahead and pull that together. So on the left-hand side, I now have a cosine x over a cosine x sine x minus the sine x now all over the sine x cosine x. And again, I'm going to carry down that right-hand side just to make sure that every single line of my proof is true or accurate. So you need to have something on the other side to see what it's truly equal to. Well, I have my common denominator now on the left-hand side, and if I pull this together, I hope everybody sees that we can actually just kind of pull this all together now. You've got a common denominator of that sine x cosine x on the left-hand side, so let's pull that all together there, and then you can just kind of push your numerators together. So I have a cosine x minus a sine x is equal to, and lo and behold, on the other side you have the exact same thing, which is exactly what we were aiming for. We want to make sure again that you have that whole reflection or mirror type thing happening. So in this case, I do have the left-hand side matches the right-hand side exactly, and this makes me happy. So I know that my proof is done there. So let's move on to the next one. So again, when you start any proof, you do need to decide which side you're going to work on. For most people, it is a little bit easier to take a lot of stuff and just kind of crush it down into something smaller, as opposed to taking something that's a little bit smaller and magically come up with all of the pieces that you need to match the other side. So in this case, I am also going to work on the left-hand side. I see more things. I see fractions to work with, I see different denominators of sine and cosine to work with, and then on the right-hand side I see a nice, neat little package of things that I think I can kind of fit this into. So I'm going to do the same thing that I did previously. I'm going to try to get a common denominator on the left-hand side. So I'm going to go ahead and get this sine x cosine x denominator. So now I have my common denominators of sine x cosine x on the left-hand side. And actually everybody has the exact same denominator. So hopefully you recall from first semester, if you have all of the same denominators, top and bottom, you can really just get rid of them. So I think I'm just going to cross those guys out and pull everything together on the top and on the bottom and just get one fraction as opposed to a complex fraction. So now I've cleaned it up a little bit. The left-hand side still doesn't look how I want it. The right-hand one, I still want it to match the right-hand side, but it's not quite there. But if I look just at the numerator here, it looks a lot like the right-hand side numerator. Kind of reminds me of a difference of squares. So if I think I multiply that cosine x plus sine x times cosine x minus sine x, I can probably get that numerator. And as long as I'm multiplying by 1, then it's okay. So I'm going to multiply the top and bottom by cosine x minus sine x. So now here I'm showing that cosine x minus sine x top and bottom that I'm multiplying by, here and here. And it's okay that I'm multiplying by that because it's really just 1, and it's not necessary to multiply both sides of an equation by 1. So just the left-hand side should suffice. Let's go ahead and distribute that out and see what happens. So now we've got it all distributed out, and I did want to show all of my steps here. And Mrs. Levitt or myself will go over the steps that are required for proofs in class. But again, for these type of problems on the examples, we want to make sure that we're showing everything so I don't lose anybody. So now that I've distributed out the top and the bottom, you'll see on the top that I have this negative cosine x sine x and a positive cosine x sine x. Those are going to cancel with each other, so let's just go ahead and cross those out. So on the top, it looks like I have the cosine squared x minus sine squared x, which is exactly what I'm looking for. But I don't quite see what I'm looking for on the bottom. But it's there. Right here with the cosine squared x and the plus sine squared x, that's one of the Pythagorean identities. Cosine squared x plus sine squared x is really just 1. Then on the inside, with the negative cosine x sine x and the negative cosine x sine x here, that gives us negative 2 cosine x sine x. So I think we're basically at the end of our proof. So by combining like terms on the top and canceling out the cosine x sine x and negative cosine x sine x, and then combining like terms on the bottom with the negative cosine x sine x and the other negative cosine x sine x, And using the Pythagorean identity of sine squared theta plus cosine squared theta equals 1, we're actually able to now get it to match the right-hand side. And the last thing we need to do is just copy down what the right-hand side is, so it looks like we do actually have a true statement where the left and the right-hand side match perfectly. So let's just go ahead and copy that down, and then we should be done. So we do say that it looks like a mirror. The left and the right-hand side match perfectly. My proof is done. Let's move to the next one. So a little bit different speed here. The left-hand side, as far as I'm concerned, is definitely the way that I want to go because it looks like it has a larger mess, more stuff to deal with. And upon inspection, it looks a little scary. But if you take a closer look at the top of the fraction here, I see 4 terms. Typically with 4 terms, I like factoring by grouping. So I'm going to go ahead and group these together. So I'm going to put the first 2 together, and then I'm going to put a plus sign and group the second 2 together. And then see if I have some sort of a GCF. Try to get those parentheses to match. So if I take a look at the first set with my cosine x tangent x, plus my 2 cosine x, I'm just going to go ahead and copy down with my parentheses or my enclosures, put a plus sign between them. That negative sign belongs strictly to that tangent x, so you're going to make sure that it goes inside the parentheses with him. Let's just go ahead and copy down the rest. Then we should be able to see if we have some sort of a GCF in common. So now that I have my enclosures around this thing, it looks to me like I can take a cosine x out of the first one, and I think that's going to give me a tan x plus 2. So to get a tan x plus 2 on the next one, I'm going to take out a negative 1. So let's go ahead and factor those out. So here we've got our GCFs factored out. This is going to work out pretty nice. Just as a reminder, factoring by grouping only works if you can get the stuff inside the parentheses to match. And in this case, it does. So it looks like the numerator has a common factor of tan x plus 2. So let's go ahead and take that out. Once the tangent x plus 2 is taken out from each of the terms in the top, we still have that cosine x and we still have that minus 1. So that's going to be the parenthesis that's right next to this one. Is going to be the cosine x minus 1. And again, bring the tan x plus 2 from the denominator with you. And as always, make sure you carry down the right-hand side. We want to make sure that every line of the proof is accurate. From here, hopefully everybody sees that you have the tan x plus 2 in the top and the bottom matching perfectly, so we can actually cancel those out. So, last thing we have is that cosine x minus 1 from the top, and, of course, the other side is now the cosine x minus 1 that we've carried down from the very beginning. We have a proof that matches perfectly on both sides. We're done. Let's go to our last one for these notes. So example 7, which in my opinion is probably the ugliest one in the examples for today's notes. We have fractions in fractions, stuff that doesn't look like fractions, but it's in the fractions on the left-hand side. And we have kind of this nice, neat little package on the right. So again, I think I'm going to work with the left, not because it's on the left side, but just because it has the most stuff to work with. So I'm going to go through, make everything look like a fraction. So I'm going to give a denominator of 1 if it doesn't have one already. And I'm going to go through and get common denominators on everything. So if I have a 1, a sine x in the top, and a 1 and a sine x in the bottom, that means everything's going to get that sine x denominator. So I'm going to multiply all of these by sine x over sine x, just to get a common denominator. So now that I have my common denominator of sine x, I know it looks like there's a lot of signs on the left-hand side. But the beauty of this is that all of the denominators on the top are sine x, and all of the denominators on the bottom are sine x. When that is the case, we just get to cancel them all. It's pretty nice. So let's go ahead and get those out of there. We don't have to worry about all of those fractions. Let's rewrite this. So as I go through my proofs, I'm constantly comparing the side that I'm working with to the side that I'm trying to get it to match. So I take a look at this and then I see I have the trig that I want. I have sine, but I've got some squares and I'm not happy about that. But if I look closer at the left-hand side, that's factorable. So those sine squareds I can turn into sines. So I'm going to go ahead and do that. Now, if you don't see the factorization, you can always do a u substitution off to the side to help. But in order to get the sine squared, I definitely need a sine x and a sine x. Then in order to get that 1, I need the 1's to match. Well, to get a positive 1 when I multiply, I need the signs to be the same. To get a negative 2, that 1 in the middle, to be negative, I need the signs to both be negative. So, if this is going to work, those are both going to have to be minus. Do a quick distributive property in your head. I get the sine squared x, I get negative 2 sine x, and I do get a plus 1 in the bottom. Or at the end. In the bottom, hopefully you recognize this as the difference of squares. So if I square root the first one, I get sine x. And then if I square root the second one, I get 1. Remember, you want 1 to be a plus and 1 to be a minus. Then, of course, I'm going to copy down the right-hand side just to guarantee that every line of my proof is accurate. Keeping my eye on the goal the entire time. I have some sine x's. This is good. And I almost match the right-hand side, just one thing to go. If I take a look here at the end, I have sine x minus 1 over sine x minus 1. We all know when you divide something by itself, you get 1. So those are going to cancel. Lo and behold, I have exactly what I'm looking for. So sine x minus 1 over sine x plus 1, and I now match the right-hand side perfectly. Now, just because these are the sides of the proofs that I chose to work on, it doesn't mean those are the ones that you have to work on. You could have chosen the other sides as well. Just as long as you get this mirror image at the end, you only work on one side of the proof. If you're going to multiply, make sure you're multiplying by 1. If you're going to add, make sure you're only adding 0. Nothing that would be required to do to both sides of the equation or both sides of the equal sign. If you have any questions, make sure you ask during class.